My name is Muhammad Imad bin Muhammad, and my metric number is 88212-519. Today, I will present about the introduction. First of all, what is flip-flop circuit? Flip-flop circuit is logic gates like two NAND or NOR gates can be used to build the flip-flop circuit. Each flip-flop has two inputs, set and reset, and two outputs, Q and Q bar. An SR flip-flop or SR latch is the term used to describe the type of flip-flop. Okay, there are four types of flip-flop circuit. First of all is D flip-flop. The second one is T flip-flop, and the third one is SR flip-flop, and the last one is JK flip-flop. So we move to the explanation of flip-flop application. First of all, flip-flop application is used as frequency divisions. The frequency divided circuit, as their name suggests, are used to produce a digital signal that has an output frequency that is exactly half its input frequency. Synchronous counter are typically designed using frequency divider circuit. Second is data transfer. The act of moving data from one register to another is known as data transfer. That kind of activities are often carried out via shift register. Flip-flop can be used to convey data in two different ways. The first one is serial data transfer, and the second one is parallel data transfer. Number three is flip-flop application is register. Shift register come in a variety of forms, including shift left register, shift right register, shift around register, bidirectional shift register, universal shift register, and the last one is flip-flop application is used in counters. There are two categories for counters, asynchronous counter and synchronous counter. So there are a lot more kinds of counters we employ, including ring counter, BCD counter, decade counter, up and down counter, and frequency counter. And last one is explanation of finite state machine, or we can call FSM. Finite state machine is abstract mathematical representation of a sequential logic operation is the finite state machine. Its inputs, outputs, and number of states are all finite. Flip-flop are used in real-world circuit to implement FSM as specific sequence of stage or algorithm is required for the implementation operation to be carried out. And last one is explanation of register. Register is a collection of flip-flop used to hold a set of hits known as a register. For instance, n number of FFS are required to store n bits of word. One bit of data can only be stored by AFF 0 or 1. When storing a large amount of data, several FFS are used in array of FFS used to store binary data makes up a register. The number of bits of digital data that a register can store is known as its data storage capacity. Setting or resetting each individual FF or putting data into the register so that FF can connect with the bits of data to be stored is what it means by loading a register. So that is all from me, and I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asir Firdaus bin Adis, and I'm from Group 4, where I'm going to present about task A. In this task, we have two five steps before we simulate our more version into a Tinkercad. So, for the first step, which we have do our step diagram. We have a sequence of more version where 3, 6, 2, 4, and 7 are connected in a pentagon, while 1 connected to 3, 5 connected to 2, and 0 connected to 4. So when we convert it into binary, it will become like this. 001 will go into next state, which is 011. By referring to this state diagram, 1 will go into 3. Then, after we have done with our state diagram, we're going to proceed with the next step. So for the second step, which is next state table, there we can see present state and next state by this table. Present state will change into a next state by referring to a state diagram. For example, present state will follow by sequence, which are 000 001, which are 0, 1, 2, 3, 4, 5, 6, 7. So when it becomes next state, 000 by referring to a state diagram will become 100. Then 000 will become 100. So after we have filled in the table for the next step table, we're gonna go to process about step 3, which excitation table. So the third step is excitation table, where we classify it into its own flip-flop for value j and k. There we have three flip-flop, which are flip-flop C, B, and A. We classify it by refer to value. For example, flip-flop C for J, 0 with white 1. It will become 1x by refer for the table uh, excitation table. And 0 with white 0 will become 0x. Then after we fill for excitation table, we can proceed to step 4, which are K-map. This K-map will simplify it value for excitation table into an expression for JC, KC, and so for flip-flop B and flip-flop A. So after we have done our K-map, we can go to process step 5, which is circuit implementation. This circuit implementation is important because if we want to simulate our Tinkercad, we need to have a circuit implementation as our reference. There are examples for our code, which we have 3 flip-flop A, B, and C, and this refer on the K-map where we use get and get or get and this so get. So for flip-flop A, which we have this one, and get and so get. That's why we put this to get in front of flip-flop A. The output will become to C, while the input will come to QC multiplied by QB bar. And these are our circuit for Tinkercad. And my friend gonna present about Tinkercad. So that's all from me. Thank you.
My name is Mohammed Osman Siva. My matrix number is AA2172. So, hello. Today I want to present about the simulation of our task. So, we use for Tinkercad to simulate our task. So, the first one, let me introduce our, let me present the circuit that we made. So for our FSM, our final step machine, our more machine, so we use 3 JK flip-flop here, and then 3 OR gate, 2 AND gate, and also 4 XOR gate lah. So this one is our circuit lah, new circuit. So this one is we use for function generator to to uh, to find the square wave for our clock. And then this one for supply power supply. And then as you can see, uh, we use two 7473, which is for JK flip-flop. This one for each IC it has a dual JK flip-flop. So we have here 4 JK flip-flop, but we use only for 3. And then for 7486, this is for XOR IC, and also for 7432, this is for OR gate, and then IC 7408 for AND gate. So I don't want to waste your time, so I simulate this circuit for you. So as you can see, this one 100 111, and then so on. So well, it will show you the step depend on based on our step machine for step diagram. So for the report, so this one is our duplicate circuit. So as you can see, 7473 is for JK flip-flop IC, and also for 7408 AND gate, 0432 OR gate, and 7489 at 6 XOR gate. So the yellow wire is connect the function generator to the clock for the IC, and the black is for the ground, and then the red wire is for the VCC. So the result, first one is 100, and then based on the set diagram. The next for 100 is 111, so 011, and then 110 and 010, and the last one is 100. So it will become for the first one, this one.
Bismillahirrahmanirrahim. Now I will show the simulation for the task bin. In this case, there are 4 JK flip-flop, 1, 2, 3, 4, and this is the input, this is the output, this is the clock pass, and this is the clear. Okay, for the first line, we need to just turn input 1 and the clear also 1, and the output is all 0. For the second line, there is 0, and the output for the output is also 0. For the line 3, there is 1 and B is 0, and the output is for FFB is 1 and the others is 0. For the line 4, we need to turn on all, and then the clock also. Then we get the output for FFC is 1 and others is 0. For line 7, also the same, and we get FFD is 1 and others is 0. For line 7, we will get FFA is 1 and others is 0. For line 8, the output for FFB is 1 and the others is 0. For the line number 9 is we need to turn the clear to 0 and we will get all the output is 0. Then for line 7 we need to turn on the clear and BC to 0. Then we will get FFB and FFC is 1 and FFA and FFD is 0. For line 11 we need to turn on input B and C and also click on the clock and we will get FFC and FFD is 1 and FFA and FFB is 0. Then for line 12 it is also the same. Then the output for FFA and FFD is 1 whilst the output for FFB and FFC is 0. Then for line 13 FFA and FFB is 1 while FFC and FFD is 0. For the line 14 FFB and FFC is 1 while FFA and FFD is 0. The last line number is 15. Then we will get FFC and FFD is 1 while FFA and FFB is 0. That's all for the simulation in this circuit, and all the result is stated in the table in the report. That's all. Thank you.